intelligence and machine learning webinar. We gathered today a very exciting team. It's multinational across many time zones, many countries, but we are united in our participation with machine learning projects and being in quarantine. So presenting Alexander Kovacevic, Anton Umnikov, David Zelter, Sergey Lukyanchenko, and me, Edward Lebduk. Everyone's from InterSystems. Some notes: this webinar would be recorded and available on YouTube. Also, we'll mail you the slides from this webinar and also a link to the recording, so don't worry, you won't miss anything. Finally, the webinar is expected to take up to 1.5 hours, including questions, which, by the way, you can ask in a chat window of this application, and we'll try to answer them at the end. 2 previous webinars are also available on YouTube. And next slide, please. So let's go into a plan. What are we going to talk about today? We start with conceptual overview of InterSystems IRIS and what's possible to do with it on the front of machine learning and artificial intelligence. Then we'll talk about how can we apply innovations in a structured and platform way. Then we go into some technical details on the model development part about how we can develop a model with Jupyter notebooks and run it immediately in platform way in InterSystems IRIS. Then some community news about Python Gateway and our new exciting Julia Gateway project available on Open Exchange. Then our AutoML offering, it's public beta now, so just in time if you want to try it. Then we talk about transferring your workloads into cloud to save time and money. And finally, we'll show you a use case demo of about hospital readmission prediction. And with that, let's start. Sergey.
Thank you, Edward, and hi everyone. Thank you for joining this webinar today. And this webinar is a format. This is that's a bit particular, and there is something common with a festival or meetup in terms of diversity of the topics that we present and the manners we present them. And on the other hand, it's a workshop because it's the number of concepts and demos that are being shown that they are expecting us to really have some deep dive into them, and really hope that this 1.5 hours that we'll spend together is going to be interesting. As Edward mentioned, this is going to be recorded, and we will structure the recording to enable the easy navigation way. So please don't hesitate if you've missed some portions to wait till our feedback mailing to the participants of this webinar and catch up using that recording. I will start before all the other interesting topics will be coming in this webinar. I'd like to start with a call to innovate with InterSystems IRIS, our flagship product for platform data management and which is more important, data exploration and data utilization, monetization in the end, if you like. And in that slide, we are combining that I'm projecting right now that we are combining on the one hand, the 40 years of history. That's a separate subject, InterSystems history. It deserves a separate webinar, but yeah, it's a 40 systems of innovation. It's all about innovation, nothing else. But we will concentrate on the now endpoint of that timeline today to just highlight the things that are really serving the purpose of artificial intelligence and machine learning in InterSystems IRIS. So just to give you a few highlights. First of all, the InterSystems IRIS platform is there for speeding up your artificial intelligence and the machine learning AI/ML solution assembly. We include into that, apart from just the fact that it happens in a single workspace, you are having at your disposal in-platform scripting in Python, R, and Julia. with your scripts being hosted in platform and then orchestrated and played and executed under the control and under the decision-making coming from the platform. The second point, which is probably deserves, in this webinar, you'll see that occupies the first place, and its central point is the advent of integrated ML, and that's the stack that is really particular in the sense that it's something that allows you to not only automate your machine learning activity, but it also allows you to drastically cut on understanding and classically also the development time to get to your model, your time to model. You are assisted in their journey by SQL, MDX, and PMML. The latter standing for predictive modeling markup language that allows you to consume models trained in external environments, and we'll see a wonderful demo from David today, touching upon that portion of the functionality. You are able to interact via gateways and most recently bridges with C, C++, Java, and .NET. IRIS, InterSystems IRIS is a multimodal platform, multimodal DBMS platform. So you are free to choose how you represent your data. You can start from a basic key value architecture and then present the data in a relational or an object format. You have integration components and processes, and that's what we call interoperability component of InterSystems IRIS, and that's something that we rely really actively upon. You'll see it from the further demos in orchestrating and actually constructing our machine learning solutions. And finally, but not the least, is worth mentioning the OLTP and OLAP capabilities that come to surface via real-time BI. So if we resume InterSystems IRIS, it will be receiving any data in any volume from any sources real time. So real time is really important here. It is about sharing results with any consumers real time. And if we make a certain accent in favor of AI/ML topic today, so it's going to be AI/ML robotization, meaning that your solutions built on our platform are adaptable, adaptive, and are agent-based. I will take you through a number of what we call emerging applications, and each of those applications are available via our platform. They are emerging in terms of gaining popularity, maybe not full 100% of our audience today is fully aware of their existence, but believe me, it comes from our practice and from our experience, they are already on the agenda, and we are facing those scenarios in the prototypes. So that's why we are covering them here. And those are the applications that are going probably to reign the scene in the next future, in the nearest future. Let's start from robotization based on agent-based systems. And that's a paradigm that requires you to build your solution not as a monolithical piece of programming code, but as a family of mutually interacting processes. Each of those processes actually having its own optics of what's happening and actually taking its own decisions by observing the signals coming from its neighbor processes and also from the external systems. It gains the terrain, this way of building a solution, because of its apparent capacity to deal in a much more flexible and finally much more performant way with highly loaded scenarios and scenarios with a high variability of processes. We also would like to cover here such an aspect of robotization applications as self-controlling. So a process, analytical process that is being implemented in platform, it is supposed to sense when the training that has been done to its models somewhere, probably in the beginning, becomes not enough. And the results that are coming out from that analytical process, they are no longer in the ranges previewed by the accuracy tolerances of the whole solution. So in that case, this situation has to be detected, and the process that is the owner of this or that model has to retrain it. And this is something that you see in that slide. It's taken from one of the live prototypes. Those of you that are familiar with the data science a bit will immediately recognize the classification model being trained. And you see it from the left column on that slide, that starting from the initial training, it improves on each training, it improves its recognition curve because it becomes more and more voluminous, so to speak. And that enables the whole solution to work more and longer periods without interruption. Continuing with robotization, we also need self-learning here. And self-learning is the ability to actually plan the training in such a way that within a finite number of trainings, our robot, our solution is capable of functioning without further retraining and is capable of before delivering a stable performance for as long a period as possible. So in this slide that is also taken from one of the prototypes implemented on InterSystems IRIS, you see a kind of recording, visual recording of in the lower part of a model being applied by a robot implemented in a platform. And in the upper part, you see a process of that robot's model being trained. So you see that the quality of its training is increasing. And in the lower part, you see that after a finite number, like 6 or 7 retrains, it stops retraining and it starts functioning. That's self-learning. Automated ML. So we've touched upon this capacity in the beginning, and we're going in a bit more details about it. Also in more details in a demo about it in the middle of this webinar. But just as presenting it as an emerging application, we need to say that this is something becomes really relevant for the environments specifically dealing with Internet of Things or dealing with highly changeable context where the whole concept of a business task that you're working with is changing very quickly. The data is changing quickly, and there's no practical way for a data scientist to manually adapt all the models by testing all the combinations of the variables. So this is supposed to be done by automated ML. And in our webinar, we will go in details and present some examples of how this can be done with InterSystems IRIS. Distributed ML. Not all the tasks, however doable they could be with our platform, merit being done so in the platform. Those could be huge volumes of repetitive model training, some data preparation work, some data scoring work. There are many cases when delegating that work to externally existing services. Most of them are in cloud format, like Amazon, Google, or Microsoft Azure. Makes real sense. And Anton Umnikov, who will be speaking, delivering his specific part in that webinar, will cover that subject in detail. Final example is the really emerging and appearing on the horizon scenario where we have to do with completely new type of hardware, the quantum-based hardware. And this quantum-based hardware is becoming really a kind of natural hardware platform for a number of tasks. So InterSystems IRIS, as you can see it from this slide here, is capable of communicating with such platforms. And we are able to implement analytical scenarios that require the running of quantum machines behind them. We are not alone as a vendor, so we have already some distinguished members of our customer audience that dared to follow us on the journey. So I'm presenting in that slide, and you'll have them available in the mailing after this webinar, together with a link. We have at least 3 public examples of our customers following with us that journey. And we know that some people from those customers are listening to this webinar, so we're proud of you guys. This is to say, we'll not probably go through all the details. You will be able to click and to listen in to the original authentic recordings from those nice people's presentations. But the point is that we are in a deployment mode, and we are gaining terrain also within our existing customer base and the new customer base with InterSystems IRIS as a platform for AI/ML. On that optimistic note, I would like to pass the floor to my colleague Alexander Kovacevic, who will speak about machine learning ops. Alexander.
Hello everybody, my name is Alexander Kovacevic and I'm a sales engineer at InterSystems. Today I would like to talk about MLOps, why it is important and how InterSystems can help you operationalize machine learning processes. Let's imagine we own an online clothing webshop. Let's name it StoreWar. As it usually goes, our company has a beautiful website where customers can look for clothes and buy it. This order is then being sent to nearby warehouse, from which it is using logistics service delivered to your home, making everything very comfortable for customers. In order to achieve this conformity for customers and be profitable as a company, it is essential for StoreWar to have a website which would maximize orders, and even more important, to make a proper supply chain strategies which would optimize costs. As ML is trending, management has made a decision to introduce machine learning into their business. They hire a data scientist which together with data engineers and domain experts brainstorm first ML use cases. A first proof of concept is being created, resulting with a brand new ML model. After successful presentation for management, it was time to put the model in production. So, DevOps has been involved. And exactly here we come to our first obstacle. Production-related matters are responsibility of DevOps, and in order to support deployments of machine learning models, DevOps have a set of demands. This is especially the case when multiple machine learning models are going to be deployed. It is not just DevOps concerns, it is also compliance team who is alarmed by the sheer impact of what ML models are about to make on business, in fear of how regulation compliant are they. So, challenge here is exactly how do we operationalize machine learning processes into existing companies' infrastructure. There is a trending new field currently investigating the topic with a goal to establish the standardized and best practices called MLOps. What does it mean? MLOps came from DevOps in similar way as a machine learning operations. And these are the processes required for machine learning projects to be successfully deployed in productive environments. Let's elaborate MLOps with a clear example. As we mentioned before, we have multiple teams within a company, each with their own expertise. Data engineers, data scientists, domain experts, which would in this example be business analysts, compliance, which takes care of companies working according to the legal requirements, and DevOps. A bit more proper way of handling ML processes would be as follows. A data engineer would extract relevant data from databases, which would be cleaned up and prepared for machine learning use case. This step is usually very iterative, together with the data scientist, as it is not always clear from beginning what data is also relevant. Depending on the case, sometimes it is required from domain expert to review data and annotate it, which means providing what would be the ground truth for each row of data. This is often required for the case when we want to replace some lengthy and manual labor with automated one. One simplest case would be, for example, when person needs to go through a list of complaints and sort them into the topics to be handled by a customer service topic experts. Annotating would in this case mean to put complaints into appropriate topic according to expertise or experience of the person doing it so far. Together with the domain expert, a data scientist would then analyze and discover what features would be useful for ML models to consider when making prognosis. These features can usually be recycled and used in multiple use cases within the business, and it is a good practice to store discovered features into a database, which is usually called a feature store. When all relevant features are found, a process of developing a best machine learning model is being made by the data scientist, which result in a winning model. This is confirmed by a training report showcasing the accuracy comparison of each used candidate models. It is a good practice to save and store all these trained candidate models along with the winning model for a multitude of reasons. For example, when any future corrections are required, each of these candidate models can be quicker retrained, so to say, training process can be resumed from already trained models. This often could result in different candidate model ending up to be a winning model. A model store is also important for sake of tracing. For example, to investigate a case when ML model at a certain date has made a doubtful decision, in that case you would need to load the version of the model deployed at that date and do further investigation. Once the winning model is made, a set of explainability reports would generate so that compliance department can look into and see and understand clearly the question why for each decision machine learning model has made. One further important point for model store itself is also tracking which version of the model has resolved which compliance related conflict. As example, when existing user requires to be removed, it might be required to retrain the models without having client's data. Once the compliance has approved the model, the task is given to DevOps to deploy it. There usually needs to exist a reason for deployment. Either it is a new machine learning model solving a new use case, or correction to existing problem, or just generally speaking, an incident. Further, what DevOps needs to know is on what hardware does this model need to run on. With rise of machine learning and deep learning per se, a set of ML-specific hardware has been especially designed with aim to decrease the training time. It does not always have to be a physical hardware. Nowadays, it could even be a specific cloud instance as an infrastructure which is required. As with every software, similar processes would need to be performed also for ML models, where build scripts and tests would be created to automatize deployments. These all need to be managed through release management, all carefully stored into a database, which we'll call here incident store, for easier tracking and follow-up of changes being made. Once the models are deployed, we need also to establish the ways how to monitor if the model still behaves as we expect. This topic itself in machine learning is called concept drift, according to the fact that if the machine learning is not behaving as expected, it is not ML model that is bad, but rather the concept of data that data scientists had when creating the model has changed, or so to say, drifted. A simplest case is seasonality of data, where, for example, we have sales data of first 10 months of the year without realizing from data that sales drastically increase in November and December. This is easy if we have a ground truth provided along with new data, for example, sales forecast, where we simply recalculate accuracy based on newly acquired data. But it is a bit more complicated when the result was based on annotated data. You don't have new data to test your model with unless you arrange that the domain expert does this manually for you. However, this is a cumbersome task and takes a lot of time, so it is not desirable that domain expert does this regularly. Luckily, there are certain scientific methods to detect concept drift without having new training data, like for example monitoring target distributions. These methods usually result in sort of say red flags, which tells data scientists that model might be misbehaving. Either way, using such methods, deployed model need to be constantly monitored to be sure decisions it makes are as expected, and if not, to be retrained as soon as possible. Let's sum up all the actors in ML process together. The key point here is to establish processes which would orchestrate smooth running of all teams. Here is where InterSystems IRIS data platform comes in play. Using its interoperability feature, IRIS data platform can interconnect different systems and teams. For example, using business process, which we'll name here model approval, we can trigger generation of model explainability reports and send the report to compliance team for approval. This manual task would wait for human interaction until the model is reviewed and approval action is received. Depending on response, for example, we can either notify DevOps to deploy it or notify data scientists that there are compliance issues and the model requires changes. At the end, we can define an activity to store each action being taken into a model store to document each version status. Further, when we talk about model monitoring, for example, we can use business rules where a company can decide what is tolerance factor for measured accuracy of models. When certain threshold of a model inaccuracy is exceeded, an alert should be raised. InterSystems IRIS offers a possibility where each team can receive notification or requests. These requests can be reviewed and answered, and each review along with response is automatically stored for easier audit. Reports could also be made in form of dashboards using IRIS BI analytics, and this way models can be live monitored. And that is not all. Within each of these departments, IRIS data platform has a set of tools that can facilitate their work. Being a database on its core, IRIS data platform can be used to store all the data like trained models, features, incidents, and so on, and provide a full toolset for data engineering tasks. Further, IRIS data platform offers companies a full palette of ML tools which can both facilitate development of machine learning models and make operationalizing of ML models smooth. Further presentations within this webinar focus on showcasing some of the toolset IRIS offers in this regard, so I will not go deep into that part. However, some of the noteworthy is IntegratedML, a great introductory tool for every company who wants to start embedding ML into their processes. It offers an easy way to automatically build a smart AI-powered applications using just free SQL commands. InterSystems works relentlessly to add more and more features to support the diverse ML communities, either if they come from world of Python, R, or Julia. As I mentioned before, one of popular ways to perform model training is using the cloud instances, which will be in this webinar in detail presented. So, as a summary, MLOps in its core aims to streamline development and deployment of models. Applying clear processes minimizes the chance of running into regulation-incompatible ML models, which often could lead into considerable losses for the company. In the area of MLOps, IRIS can be an essential piece orchestrating whole machine learning processes and making every step within these processes transparent. In the end, it is worth mentioning that seriousness of the topic has been recognized by Gartner analysts, which has evaluated MLOps having a significant impact to machine learning projects in 2 to 5 years. With this slide, I would like to thank you all for your attention, and I'm looking forward for your questions, and I would like to hand over to our next speaker. Thank you.
Thank you, Alexander. And now I would go into detail about the part of model development and some exciting community tools. All right, so when we talk about model development and a more project-oriented model lifecycle, I'd like to start with CRISP-DM, which is a nice but very generalized methodology, so everyone can agree on that, hopefully. The difference is always in the details. All right, let's do a quick rundown. First, we determine validation metrics. We decide how can we confirm that predictions made up by our currently non-existing model are actually true. So we can be sure that they can be acted upon. After that, we explore the data, normalize it and extract the features, and all this can be done with InterSystems IRIS because it allows real-time delivery of data in any quantity and quality. After that, we build the model and validate and actualize it, because first of all, when we build the model, it passes our checks. It works, because if it doesn't, we didn't build the model. We need to adjust something. We add more data. We change the model type, change some hyperparameters, and so on. But at some zero point in time, which is, so to say, the start of production use, our model works, and it works good enough for it to be in production use. The problem is it doesn't stay that way. After a while, the model just stops working. Data changed. There are some changes in the way things work, and the model doesn't produce actionable results anymore. Unfortunately, it doesn't notify anyone about that, but InterSystems IRIS can do that by checking that model produces results consistent with what we expect, and if it doesn't, we can automatically actualize it, retrain it, or change the parameters for it, and all this allows us to productize the model. Now, for training the model part, for many data scientists, Jupyter Notebook is really the tool to use, and now we have added to community project Python Gateway, InterSystems IRIS, and Jupyter integration. You can create new processes, delete process, and modify them always. I'll show you how it works. Here's our Jupyter Notebook, but it doesn't point at files, it points at classes. Here's our test process for Python Gateway. Here's how it looks like in Jupyter Notebook. And here's the same process in InterSystems IRIS. It's interoperability business process. They look the same, only in Jupyter it's flattened out because it cannot show parallelized things and control flow and so on. And I'd like to create some new process just to show you how simple it is. Let's wait a little. Yeah. We create a new test activity, and we write some code. This cell is marked down. It's our name. And we save our process as IC test try. Saved it. It's available in here. But more importantly, we can immediately plug it into our interoperability production. Test it. And see what happened. On visual trace, you see what code was executed, at what time, how much time did it took, and what results did we get. So, and all this is available from Jupyter Notebooks. It's already available on Open Exchange. Next part, I'm going to talk about is Python Gateway, our long-standing community project. And recently, we added a new improved data transfer. So if your data is stored as classes, tables, or globals of this structure, it's the most popular structure there is. You can use new and optimized data transfer, which is 20 times faster than old Python Gateway transfer. For a test, I transferred 300 megabytes global into a data frame, and it took 20 seconds. It's also a very wide global, 6,400 columns. Also like to show it to you. There is a sample available on Python Gateway project, and you can see that there's comparison of transferring the same data via global, via table, via class, and via query, and via class global, it's 10 times faster, but depending on the workload, you can get even better results. Checked out. And finally, Julia Gateway. So Julia is a new dynamic programming language. It's way more recent than Python. It's general purpose, but mainly it's a math engine language, similar to MATLAB and Octave. It's as a math engine, portfolio supports symbolic calculations, which is interesting in some situations, in some more. In stricter workflows, it's cloud-oriented and it's parallelized at its core, and it really tries to allow you to do parallelized computing by default, and like Python, where there are some known issues with parallelization. So Julia Gateway, community project. It adds Julia to InterSystems IRIS. You can execute arbitrary scripts. You can do bidirectional data transfer. You can do control flow, and you have interoperability adapter. It's available on Windows, Linux, Mac, and Docker. Download today. All right, another demo. Here's our data set. It's called MS, and it's about house pricing. We have some information about houses, such as square area, garage area, floor number, neighborhood, overall quality, year built, and so on. And we have a price. And our goal is to predict the price based on all these independent variables. Here's how Julia Gateway process looks like. Again, it's all completely the same as the Python Gateway, R Gateway, our existing community projects. The idea is the uniform experience across all these tools. For example, to load data, you just need to write an SQL query. Nothing can be simpler. You don't need to think about JDBC, ODBC libraries and credentials. It's all in process. You just write your query, you write what variable you want the data to be placed in, and it's done. It's a simple process. Here's our model. It's a KNN model and one hot encoding before that. Let's run it. And at the end, it actually writes back into the InterSystems IRIS platform. So we can see the results. Okay, here's our visual trace, and you see all what was executed, how much time did it take, what line, and if something went wrong, you can immediately see what happened. You can get the data back. For example, we write what variables we want back, and here they are. It's our model prediction results. Yeah, and you see that price predict is filled, and we can see the difference between predicted price and actual price in persons. Yeah, so Julia Gateway, it's also added in a terminal. Here's an example. You can just have a Julia shell or in you can just call it from object script. Let me show you my favorite example. It's cubic root, and it's actually a valid Julia symbol. First time I was executed in from Iris, I was completely blown away. It's actually a valid command. But I think that's it for my part, and I'd like to give a word back to Sergey.
Thank you, Eduard.
And the screen too. Don't forget to ask questions.
And we'll pick up from here. Thank you, Ed, actually, for giving a good introduction on in-platform scripting. So that's something that mostly describes, say, has been described till now, the so-called manual proceeding with machine learning and artificial intelligence solution build up, but now we're with the automated ML, and we'll be going through automated ML in a second with a concrete example. But before that, I would like just in a couple of words to clarify about the concept. The concept, beside the fact that the machinery behind this stack in this engine inside our platform is really versatile. The usage has been intentionally made easy, especially easy for the people who are adopting this. So the most frequently, the most repeatable operations in artificial intelligence and machine learning, such as model creation, training of the model, prediction, and validation, or sometimes first validation rather than prediction, have been formulated as the 4 SQL instructions, and the usage has been harmonized with the usage of plain SQL. So that opens up the access to using machine learning and artificial intelligence to either the public that has never been exposed to that before, or to there's another, end of the spectrum, to the individuals that have had enough of it and would like to save their time on building quickly some prototype, testing it, sensing its validity before actually going productive with it. So one way or the other, the operating mode starts from our SQL window in InterSystems IRIS. And once a query has been formulated and sent for execution, it's then passed to several alternatives in terms of execution software. And we have 3 software stacks currently available behind the scenes, namely H2O, wider known for those that are open source adopters. Another nonetheless popular stack, Data Robot. And there is another stack developed by us called Default Automated, or Auto ML simply, developed by InterSystems based on Python libraries and the Python script. So depending on which provider you've chosen, then it's in provider's responsibility to understand your query and formulate for you, to build for you a model that looking at your data set is, first of all, is based on the optimal family of algorithms, and secondly, has the right parameters adjusted for you. So that second remark about right parameters, that includes also the choice of input variables, and anyone that has been exposed to data science tasks knows how tedious and how, in the end, how non-obvious that choice could be. So, so that I would say is the essence of automated ML functionality in InterSystems IRIS. And let's have a quick look at how it works. We'll be using an example that is probably close to any company, to representatives of any industry that are listening into this webinar, because this scenario is based on marketing, and most of the marketing people are doing campaigns, and they're doing it by actually looking at least so at the naive level by studying the history of the previous campaigns. So we will be, in this scenario, we'll be attempting to build a model that learns from the history of previous marketing campaigns and pre-selects for us an audience that is optimal in terms of gains and costs ratio. So meaning that not whole 100% of the potential audience gives you the highest ending resulting cash flow from the marketing campaign. So let's first use integrated ML in the discovery mode. What is the first step that usually a analyst starts from when he or she is building a model? We need to define that model. And usually for doing that in a manual, traditional way, we would go somewhere either directly into one of the mathematical modeling environments, or if we're in a platform, we'll be then going into creating a specific activity like Edward was showing it several minutes ago, and we'll start writing a code in Python, R, or Julia, or any other language. In this case, we're doing it differently. So to create a model, and I'm switching now to my system here with all the necessary commands prepared, so not to waste time on entering them. So to build a model, first of all, I do a technical step. I'll drop the previously created model so we don't conflict with the same model identifier. Say execute, it's been deleted. And now, if I go here, and I uncomment the create statement, so this is a create instruction, treats like create model, then the name of the model, and then the target variable that this model is supposed to predict. So we have a classification task. We have to predict a response from the history of the previous marketing campaigns. So we need that response taken from the history, and where that history is in a table called campaign train, right? So that's the table in my database that is also here in IRIS platform, and using which provider, which software framework I'll be building my model. So I indicate H2O, it's my preferred one, as a provider. All right, so we're all set. So now I can say execute. And my model definition has been created right now. So to go ahead further, I need to train that model. So this is something I will do right now. So please pay attention. I'm not leaving that SQL window, and I'm doing it all step by step without going anywhere. Train. So I will issue another instruction, train model. Which model? H2O, the one that has been created previously. And what kind of record set it will be using to be trained? It will be using the record set that is provided by a select from the same campaign train, the table in my database that contains all the data. All right, so let's do that. Take us several, probably tens of seconds, and please keep in mind while it's working, it's doing the tremendous work behind the scenes. It's studying all the possible candidates for being called features for that models. That means the input variables like age, like education level, like different types of income, and so on and so forth. And it will finally pre-select for us an optimal set of features, input models that will deliver for us the best accuracy based on the data that it is seeing in the table campaign train. All right, as you can see, it has finished working pretty quickly. And we had 40,000 of records in the training data set just for the story. So which gives me the possibility now to apply my model and to run a prediction in this discovery mode first. That means just in front of my eyes in that particular screen. So I'm issuing another command, starting from select, because it will be like doing a select query in principle. And then in the select query as the first column, it should show me the probability of a response, the response variable being 1 or 0, based on the training model, on the training dataset, campaign train, that it has been trained upon. So let me now start that one. Takes us a while, and then now you can see that it returns to me practically the data set that I used for training. So let's take a quick look at what has been used for training. So we had a column called age, we had education, we had marital status, occupation type. And oh, by the way, all those variables, as you can see, they're categorical, so it deals with categoricals without any prior preparation, which we've just thrown to it the data without any sort of one-hot encoding or anything like that. Relationship, race, gender, even prospect ID was participating in the training, which is definitely a taboo for most of the data scientists that are present on the call. Employment type, years of education, country of birth, and so on, ending up with a response that it was not using for prediction. It was used only for training. And we see mostly zeros in the beginning of the table, which corresponds nicely to the prediction outcome, to the forecasting classification outcome coming from that automated ML modeling session. We see that the probability values are really low, and that means in terms of interpreting those values for the analyst, that means a 0. All right, so this has been something, and I'm getting back to my slides here for a second. So we've covered the creation of a model, training of a model, application of a model, and as you can see in the right part of that slide, just without leaving that SQL window, we've covered a fair 50% of the task, right? So that's the discovery phase. And now, if we are fine with what we've seen as a performance coming from our data set and from the analytical actions and analytical transformations we've been applying to it, so we can now go and productize it. So I'm switching now from the SQL window that I've been in for the last couple of minutes. So I'm switching to the graphical analytical process composer in the interoperability part of InterSystems IRIS. So this has been shown by Edward, and he has explained in brief terms how those processes work. I will not be probably repeating all that, and I'll scrolling you to the most interesting portion here. So to model, to create a predictive model based on the history of marketing campaign, we're not relying only on one model. So we are using 1, 2, 3, 4, 5 manually created pipelines. That means the pipelines that have been created by a human brain, including the choice of input variables available in the data set. And there is one model here that is based on our integrated ML. That means automated ML frameworks are working behind the scenes as part of that competitive model mix. And then the process is defining the best performing model here using certain tools like rock curves, special sort of visualizations that allow us to judge on the quality of modeling. And the winner model is then taken further through that process to perform a simulation of optimal audience and maximum gain. All right, so that's the full already productive scenario that is really supposed to be launched periodically and to deliver to us the scoring of the newly acquired audiences in terms of which percentage of those audiences should be covered by our marketing campaigns to obtain the maximum gain. So the brick here in that process that corresponds to automated ML, I'm highlighting it. So if I open it up, I scroll a little bit, you'll see that in a slightly different syntax, but all those commands I've been using in the SQL window are now available as part of that activity in the process. So I can use the application of those commands programmatically, still without knowing a bit about how to operate H2O. So I don't need this. I have my integrated ML syntaxes here, syntax to actually do what I need. Probably the only difference being that instead of visualizing a select on the screen, I'll be using some inserts to insert the end results of that modeling in my tables here. All right, so let's launch that process now. And while I'm doing that, just a quick remark. In my file system here on my laptop, all the results that are coming from that analytical process will be put in that folder. Let me start that process. Sending it a message to trigger it's being started. So it will work for approximately 1 minute. And while it is working, I'm just continuing a little bit the story about this particular branch. So it should now extract for me the results of the model feed to evaluate the quality of the modeling produced by IntegratedML against its competitors that have been created by human data scientists. I will extract also the results of that model being applied to the testing dataset, the dataset with a newly acquired audience that needs to be scored in terms of the attractiveness of being covered by our marketing campaign. And I will do a manipulation to extract what is called here for brevity coefficients, but basically it will reflect the relative importance of the attributes of the features that IntegratedML has found in the training dataset and has been pre-selected by IntegratedML used in the model. And now we can observe the relative importance of those inputs in terms of impacting the behavior of our target variable, which is the response. So let's check how it's doing here. I'm doing fine. Yeah, it's finished. It's finished executing, and I can now switch to my file system. So I see some graphical files here. I open the first one, and I see here a comparison of the ROC curves of all of my 6 models that participated, that were actually processed by this analytical process. And I see immediately that the maroon, the brown line representing H2O, that means the AutomatedML framework that is being orchestrated by IntegratedML as part of IRIS platform, has shown the best result. I see that it's the best result because it's covering the biggest area on the curve, that brown line. All the other curves represented by multiple colors and actually standing for all different other methods, but which have been configured and applied by a human data scientist, they performed less brilliantly compared to what we see in the case of H2O. So this is a zoom in to show that really in the narrowest portion of the graph, H2O prevails. And if we take a look at this one, so we see that there is also, we can also judge on the importance of the features that have been automatically analyzed by IntegratedML, and we can compare their importance based on the modeling outputs produced by H2O. So for example, we see that in the end result, in the behavior of our response or non-response to the previous marketing campaigns, investment earnings of an individual have played probably the bigger role than the years of education. Then we have a type of work week length, 40 hours or more, and maybe also some investment losses. We see some punctual influence produced by age, and we also see some negatively correlated, surprisingly, but that's the fact, negatively correlated impact produced by the amount that it observes on the history of the previous campaigns. So we have also some intercept that is a fixed fixed influence that exists independently from the other factors, but at least the factors that are above the intercept, they are talking to us in terms of also very valuable information as to which features, which variables from our previous history are the most influential. And believe me, to come to such an understanding, a human data scientist would need to spend, I'll say, many nights. So by wrapping it up, we need to mention that, yes, we now have the ability to not only implement ad libitum analytical processes using scripting, like it was shown by Edward and the colleagues. We can delegate a huge portion of work to AutomatedML And the example that we have been showing here is of course, we can say it's relatively easy, but this could be also applied to a number of more heavy scenarios, like industry Internet of Things, when we need to analyze thousands of columns. And many times we don't have even the capacity to write them out one by one in an SQL query. So that's a feature that is in there, and we are inviting you actively to join us in the discovery of that functionality in InterSystems IRIS. So with that, I stop sharing and I pass the floor to my colleague Anton, who will be talking about distributed ML. Anton?
Thank you, Sergey. Let's get started. Can you see my screen?
Yep. Oh, wait, not yet.
Very good. Okay, let's get started. So, machine learning, artificial intelligence, it's all very cool. It can do fantastic things. At the same time, one thing you might have heard about machine learning, that it requires a lot of compute resources and dedicated hardware. I do like numbers, and for instance, I want to bring to your attention a couple of numbers that Sergey used in his part of presentation. On the data set of 30,000 records, it took around 30 seconds to train the model. Now imagine this set would be not 30,000, but a couple of million records. This webinar probably would be way longer than it is already, right? It would take a lot of time and resources to crunch the numbers. The typical approach to that is to use dedicated hardware for machine learning, right? And this hardware usually includes either GPU, graphical processing unit, that is very good for massively parallel processing, which typical machine learning process is all about, or dedicated hardware like cloud GPU tensor processing unit that Google offers. Right? Let's look at some other numbers. Here's the typical dedicated machine learning workstation. It has 4 NVIDIA GPUs, a bunch of CPUs in memory, and the price tag is just under $34,000. You can buy that today. Right? Alternative would be to rent this machine from the cloud provider. Like the comparable machine at AWS Cloud would cost you 17, there is a dot, not comma there, $17 an hour for the same 4 GPU powered machine. Right? If you'll do a little bit more number crunching, you would think that you would break even in 82 days. So if you'll put your IRIS database on these 4 GPU machines, it would be the same as paying for cloud instance for 82 days. Still doesn't really make that much sense, because database activities, they rarely use any GPU. Frankly, they don't, right? Unless you're doing some machine learning, and machine learning you're doing only for a fraction of the time. So the better approach would be to use some dedicated services in the cloud that use these powerful instances only for the moment that you actually need to train your model. In Amazon Cloud, this service is called AWS SageMaker. So SageMaker is the set of tools and services that let you train, configure, and run your models in Amazon Cloud on these powerful instances, right? I'm in the SageMaker dashboard right now. I can see that everything is gray, so nothing is running at this point, right? But I had quite a few jobs that has been completed recently. I can start one of these jobs in SageMaker right from my IRIS instance. Thanks to the Python gateway that we now have, thanks to the community, I can go and run the code that would connect to AWS Cloud, push the data there, start the training job, do all the training for your machine learning model, and push the model back to my instance so I can do inference. I can apply this model in real time to my data, right? So this cloud instance would typically be some heavy instance with GPUs attached, but we'll use it only for the fraction of time, right? So if I'll refresh the screen now, I can see that one new job is running. We have 6 jobs completed. If I look at the jobs that are already completed, right, it gives me a bunch of statistics, but the most important statistic here is billable time. So I was using this GPU-powered instance for 89 seconds. So even if we'll take this number of $17 an hour, like we used barely over 1 minute of that time. So we're paying way less than $17, right? And the beauty of these cloud services and the ability of integrating IRIS with the cloud services that Azure, AWS, and Google provides is that you can spin these powerful instances exactly for the moment you need to train your model, save a lot of time, a lot of money, and then run these models within your instance. If we'll get back to the presentation, right, I'll show you some numbers that we get running another model little bit before this presentation. This model is opt to vector, right? It's an algorithm typically used in natural language processing. So basically analyzing large bodies of text. We run it on 2 instances. One is standard CPU only instance, right? That cost 28 cents an hour. And the time to train our model on that instance was close to 14 minutes, right? And total price, 6 cents, right? If we do exactly the same training, right, on the model with just a single GPU, the price per hour goes up significantly, but the time it takes to train the model drops down, right? Drops down almost 5 times. And the total price we pay for training our model is even less. We're paying 5 cents. So thanks to community run effort and Python Gateway, we can not only run machine learning models on the instance where IRIS is sitting, we can push this workload off to the dedicated services, dedicated instances in the cloud, and we can use them only exactly for the time we need to train our model, which results in a great savings in both of terms of time and money, right? In that simple example, it was 5 times faster to do that using GPU-powered instances, and a little bit less expensive than comparable workload without GPU. On that, thank you very much. I hope you'll have some questions down the road, and I'll pass the screen to David. I'll show you some practical examples of what you can do with IRIS and machine learning.
Thank you very much. Just a moment.
A small note while we wait. I see a lot of people joined us a little later after initial announcements, and I'd like to again remind everyone that this webinar is recorded and you can check it out on YouTube later. We'll send everyone an email with slides and with YouTube link, and you can ask questions in a chat window. David, we see your screen, so if you're ready, you can start.
And unmuting your microphone back, Dave.
Sorry about that.
Yes, there we are. Sorry about that. Hi, I'm David Lepselter. I'm a data scientist here at InterSystems, and I'm going to do something slightly different. Namely, I'll be walking you through a machine learning project my group here did for the sake of demonstrating how we can use our technology to solve a specific real and pressing problem. I'll do my best to not dwell on any of the less important parts, and if you want to ask me questions about any of those, that can be during the Q&A session. Before I get started on the solution, I'd like to take a moment to describe the problem. Hospital admission is expensive, but of course it's often necessary. What isn't always necessary, but is still expensive, is readmission, which is to say, a patient being released from the hospital only to be admitted again within the next few weeks. In many cases, these readmissions are preventable. Some important detail fell through the cracks, like for instance, the patient didn't understand that the medication they were prescribed needed to be taken on an empty stomach, and that they couldn't eat for an hour afterwards. In this case, all that really would have been necessary to prevent readmission would have been a quick follow-up call from a nurse, say a day after release, making sure the patient is taking all the medication exactly as prescribed. That kind of intervention might cost the hospital under $100, but save both hospital and insurance company thousands, while also ensuring the patient gets good care. But scheduling a follow-up call from a nurse doesn't make sense for every patient every time. It's best to try and predict which patients and which visits are most likely to result in a readmission. There's been a great deal of work done on the problem, but the most promising approaches involve machine learning. Conveniently, that's my specialty. So I'm going to show you how to do it. We'll start by mentioning that IRIS for Health includes an automated interpreter for the common medical message standards, including the one called FIRE. So we start off with a good way along the path from raw data to interpretable data. Here in our data lake, what that gives us is a series of tables. Patient demographics, information on individual hospital visits, information on when individual patients were diagnosed with what condition, and also some extras that we put in, like for instance, translation between one kind of medical code and another, or translations from medical code to English for those of us who don't speak medical code. Now, this is great, but it's not yet something we can feed into an algorithm. Not yet. What we need here is a single table comparing all or containing all relevant information, including what's known as the target. Here's where you need someone who understands the data. What's potentially important to the question of whether someone will be readmitted to the hospital? And so we've gathered together the things that might theoretically be important. Length of stay. How long has this person been in the hospital? Whether the person is a smoker, what age this person is on discharge, number of admissions in the past month, in the past 3 months, 6, 12, number of things that the patient has been diagnosed with in the past little bit, whether the patient recreationally takes alcohol, drugs, year and day of week, day of month, month of the start of the hospital visit and end of the hospital visit, the reason for admission, the gender, et cetera, et cetera, et cetera. Also importantly, including the comorbidities or the conditions that the patient has been diagnosed with, and the current comorbidities or the reason why the patient is in the hospital this time. And of course, also will readmit. This is something that can't be calculated at time of dismissal, but is important for training the model to predict whether or not this is going to be a readmission. Now, so we've added a little extra dance here, including intending to make the entire process easier in the future. That said, if you're not comfortable with IRIS's Deep Sea Architect, I should mention that all of this is entirely possible with some clever SQL, still all inside IRIS. If you are comfortable with the approach, though, we've added one more bit of convenience that you can do some of the data prep with for extra control over the process, the analytical base table. This takes a deep sea cube and allows you to normalize numeric data, one-hot encode categorical columns, replace nulls with various kinds of values, drop columns that we don't want to include in the calculation but still want it in the cube. All of these things are optional. But depending on what you intend to feed the data into, this may be helpful. I'm going to be feeding the data into Spark and using SparkML, which has its own data prep options. So the automated, also the automated ML options shown earlier in previous presentations have their own data prep also. So I'm just going to use the most basic version, which will one-hot encode a couple of things Spark would normally have trouble with. And voila, what we get is a list of basic things involving whether this particular person has this particular condition, whether, or what age they were at the time they were dismissed, et cetera, et cetera, et cetera, all those things that I mentioned. And this is in a convenient form that that Spark will deal with well. I'm not going to go through the Spark notebook. It's lovely, but it has relatively little to do with IRIS itself. This is just a workflow that a data scientist might reasonably go through if they're trying to use their own technology instead of, say, the automated ML or SageMaker or something along those lines. What's important is that at the end of this, it outputs something called PMML, which is a language that is used to describe a model that is independent of whether it was trained in Spark or on SageMaker or wherever else. And IRIS has convenient options for being able to import a, for instance, random forest model. We are importing this as the model named T2. And it's going. And it'll take a little bit because this is a fairly large model. It's got a lot of data in it. But once it's done, and it's in there, and we can query this. here we are. Let's try querying it. Look, we have a response back. Probability that the patient will be readmitted is 11%, or 11.09, and probability that the patient won't be readmitted is essentially 89%. So that's convenient. It means that it can be put directly into a production anything, including, for instance, a UI. This part I had relatively little to do with. This was done mostly by other people on my team. But for instance, you could say, hey, look, this particular person who's going through Frederick Masters has a 49% chance of readmission, but let's change some of those details. Let's say that instead of just sending him home, we are going to send Frederick to a nursing facility, and it will recalculate. Hey, look, the chance of readmission has gone down significantly. Not, you know, not to zero certainly, but it's gone down quite a bit. So we can discharge him to the nursing facility. That is the basic idea of including your data scientist workflow into an entire IRIS solution, which will then be able to utilize it in real time. And from there, I am going to stop because we are over time, and hopefully you will have some good questions for me.
Thank you, David. Demos are always the best. Now, I'd like to remind you once again that you can ask questions using the chat window. And while we wait for questions, I'd like to sum up today's webinar. We've seen an overview of AI and machine learning capabilities of InterSystems IRIS, some exciting new features, seen how ML operations can be deployed, seen Jupyter notebook integration, some community news with Python Gateway and with new Julia Gateway. Finally, IntegratedML is in a state of a beta now, so if you're interested, you're just in time to join. CloudML can save you time and money. And finally, we've seen a live readmission demo. We have a few minutes left for questions. So some other notes, I guess. This webinar is recorded, which soon be available on YouTube, and we'll send you the link and the slides in a follow-up email. Well,